We launched in the middle of the night, on a night when we were kind of wondering whether we were going to go fly or not. We finally got to go ahead and suit up. This is my favorite piece of gear to put on. Very, very comfortable. Here's Borneo putting on his suit for his first flight. You see John Grunsfeld on the right. Everybody's raring to go. We had a sort of a marginal call from the weather guys, for those of you that followed it. Sam on the left and Ron on the right. We're all kind of thinking that this is sort of a dress rehearsal for the real launch day, which would probably be the next day. Tammy putting her suit on, and Wendy. Suit techs did just a marvelous job. I think we may be one of the last flights that actually wears the LES as we get ready to go into the ACES suits. But we were all fired up and ready to go, and lo and behold, we went to fly.
Here we are, starting the main engine 7 seconds before launch. Of course, a little over 1 million pounds of thrust there. 2 SRBs, you see the twang maneuver, Steve in the left window, 2 SRBs lighting basically 4.5 million pounds of weight and 8 million pounds of thrust, pushing us upwards. Instant daylight. Obviously, you can see how well we illuminated things. John and Wendy were able to actually see the launch pad, the smoke plume, and the coast by looking back through a mirror. And obviously a majestic sight for everyone as we quickly disappear from sight here. And approximately 2 minutes, we approached the SRB SEP, which of course gave us a beautiful view of the forward rockets as they separated inside. And we were on our way to orbit.
Well, here we are, a little over an hour into the flight, just witnessing this beautiful view of the Earth. But Flight Day 1 is extremely busy, and so we needed to get to work. We opened our payload bay doors a little over an hour into the flight. And then soon we'll be activating our Space Lab pallet and activating our instrument pointing system, all of which is done from the aft flight deck. Once we attach our telescopes to the instrument pointing system, we deploy that IPS and instruments to the upright position. And then a little bit later on, we'll be doing a thorough checkout of the IPS and also a checkout of all our ultraviolet telescopes in preparation for the next 15 days of astronomical observations. From the left-hand side, I work the IPS side, and Sam on the right-hand side is doing the instrument checkout.
We were able to very quickly settle into the routine. I was responsible for making sure the orbiter was pointed at the right part of the sky. Tammy was responsible for fine-tuning with the instrument pointing system. And then the telescopes would lock onto the target. And you might be wondering why we're looking at the Earth, but we're currently rolling to the right attitude. The idea was that we would pick up a star as it rose above the Earth's limb, and then Sam would go to work making sure the experiments were ready to start the observation. And quickly, we have the Astrostar Tracker on the left, UIT, HUT is right in the middle, and Whoopi is on the right-hand side. A very, very capable package of telescopes. It really did an outstanding job.
We had a number of tools on board to help us evaluate how we were doing. We communicated to the telescopes primarily through the small laptop computers. I'm issuing commands directly to the telescope, and you saw Tammy issuing commands to the instrument pointing system. This is what we would see through the Hopkins ultraviolet telescope. It had a TV camera that actually looked out through the telescope, and here you see an acquisition of the planet Jupiter. We're actually looking at the space around Jupiter, and displayed below that was a spectrum that we're actually acquiring. Here you see the Wisconsin ultraviolet photopolarimeter experiment in the foreground, and this is the type of image we would get from the Whoopi instrument. This shows a star in the acquisition camera, and in addition we had the spectral data from Whoopi also to evaluate the target to make sure that we were looking at the right target and the data was good.
Well, what ended up being a very, very short checkout period. We got into the routine of observing target after target for for the rest of the mission. John and I were the redshift back end of the bus operators with Borneo in the front, and Borneo would do a maneuver of the orbiter. John would maneuver the IPS to the correct attitude, turn the manual pointing controller over to me after the IPS maneuver was done, and I would do the target acquisition on the CCTV displays, and the telescopes would be set off on their way observing the object. And here again you see the CCTV displays that we had on board to make sure we had the right target.
This information was also available to all the scientists on the ground, and there was a huge team working at Marshall, as well as all the folks here at Mission Control working. And here we see our alternate payload specialist, Scott Jernigan, and we are in regular communication with the APSs and the other folks at Marshall working the telescopes. Every day they'd send us up a few pages of new information on new targets and target procedures, and also all the orbiter procedures and information. And so that was part of our duties on board to incorporate that into the Rolodex. And Tammy helping me out there. That was part of our daily activities. We also had, as I mentioned, the mid-deck active control experiment. And here you see it with the disturbance at the far end on the right there, disturbing the whole structure. And that's free-floating or near free-floating in the mid-deck. And in just a second, you'll see the control take over, and the left-hand gimbal suddenly locks in, even though the right hand is still disturbing. And this was the way it worked most of the time, quite well. Here's a case where the left-hand side is supposed to be pointing inertially in space, but obviously this is a oscillatory divergent case where the control wasn't quite enough. And you wouldn't, if this were a space station, I don't think you'd want to be aboard. And these were fun to watch, but by far the minority. And this was just a great interactive experiment, as you can see by the expression on our commander's face, and Borneo Bill to the left there.
Fortunately, the other mid-deck experiments were rather benign. We just spent most of our time cleaning the filters on the protein crystal growth experiments. You can see John here participating in a medical DSO that was determining the function of the eyes and the head, your gaze on orbit. He's definitely wired for sound in this scene. And again, Dr. Saraks, also known as Ron, talking with one of the many school contacts. We spoke to schools literally around the world, India, South Africa, as well as throughout the United States. That was really, again, as John said, one of the more enjoyable aspects. And of course, we'd had to include Bill on the bike. He had to arm wrestle the rest of us for time, though. He didn't live on the bike. We actually made him work. But as I said before, it was a great way to get some exercise and to relax while you're on orbit.
Well, that exercise is likely to make anybody hungry, and some of us were hungrier than others. As we see, Borneo here was first in line at the galley. Redshift usually had dinner together. We usually had a cocktail hour first where we all had a shrimp cocktail. Here you see a blue shift person coming in here, probably didn't have enough breakfast, trying to get somebody's food away from them. And of course, playing with food, you know, no matter how often your mom told you not to play with your food, it's just impossible not to do that in space. And you see Tammy here with fluid physics experiment, some tropical punch floating free in the mid-deck, which she was able to vacuum up post-haste. And of course, we don't have a shower on board, and that's the best you can do.
Earth observations, as we said, was one of the more enjoyable things to do, and also an important part of the shuttle program. And here is Wendy's famous Barren Island volcano in the Andaman Islands. And that was neat to look for that kind of stuff. That was a great discovery for us to be able to report that to the ground. Again, Shark Bay, this is a larger view of it. And from day to day, we could see variations, both due to tidal differences and also from the rain in Australia. This is looking towards the south. Up at the very left end of the picture is Adelaide and some of the dry lakes in the Ayr Lake region. And some of these also had water in them. And we had both color visible film and infrared film, and we took sometimes pairs of pictures of the same region. We also had an opportunity on a number of passes to see the Hawaiian Islands. Tammy showed you the Oahu view. Here's the big island of Hawaii. And on the top of the picture there on the volcano are a number of NASA observatories that also do astronomy. And we really enjoyed taking the pictures.
This is another beautiful view of a sunset on orbit. It takes about 90 minutes to orbit the Earth, and so one gets to see a sunrise or sunset every 45 minutes. And this is one of the storms that we witnessed in the south central United States. You're looking north is at the top of the screen. To the left, you can see Louisiana, all the way up to Atlanta, actually. And on the right-hand side, of course, is Florida. And it's a very graphic depiction of city lights and storm activity.
Eventually, we have to come back home. This is a graphic visualization of the pilot DTO. You can see an actual approach here on the computer screen, working with the controller, which is mounted to the existing stick on the orbiter. In addition to that, prior to coming home, we went ahead and did a check on the flight control systems. And what we do is we do a check of all the jets and also the flight control surfaces to make sure that the orbiter does perform as advertised. And here, the three orbiter folks, Steve, Wendy, and myself, are going through the flight control system checkout. And you'll now see the Elevon moving in the background. And you can really feel this just shake the vehicle as it slams back and forth against the hard stops.
And then the final step before we come home is to turn the orbiting observatory back into a flying machine. And it gets kind of hectic there when we're trying to pack everything away and then put our launch and entry suits back on and get ready to re-enter. Here you see Ron and I, and our Suits Are Us logo there, putting Borneo in his suit. Once that's done, then just before we deorbit, we close the payload bay doors and seal the payload bay so that we can re-enter the Earth's atmosphere.
As you're probably aware, we were originally scheduled to land at Kennedy Space Center on the 17th of March, which would have been 15 and a half days on orbit. Unfortunately, the weather in Florida didn't accommodate that landing, so we put the telescope away, never did actually close the doors. The Mission Control Center folks never put us into the suits because the weather was so bad they didn't think that we had a chance at it. The next day, Saturday the 18th, we made one look at the Kennedy Space Center, waved off on the first rev, and went ahead and burned to Edwards Air Force Base on the second deorbit opportunity on the 18th. There you can see the hack. We're on final now into runway 22 at Edwards, and the winds were a little bit gusty at Edwards. You can see a little bit of the dust coming off of the lake beds, but there wasn't an appreciable amount of turbulence. We could feel a little bit of turbulence on final, and the right to left crosswind was definitely noticeable, but nothing that wasn't well within the performance capabilities of the orbiter. And for those of us that have flown before, there wasn't a whole heck of a lot of difference between an 8-day to 10-day flight and a 17-day flight. So if there is a limit on the amount of time that people can go to space and come back and land an orbiter, we don't think it's at the 17-day point. It was a wonderful flight. We had an orbiter that gave us virtually no problems whatsoever. The folks down at Kennedy Space Center should be very, very proud of the orbiter that they gave us. We hope that we gave it back in pretty good shape to them so that they can turn it around for the next bunch of folks that go fly it. It was a tremendous adventure for us. We were very pleased with the results. I had a tremendous group of people to go fly with, exceptionally talented group of folks, and so if we just go ahead and start the slides now. Okay, the crew patch, as is traditional, the rookies are pretty much responsible for the crew patch, and we think that they did just a great job. Pretty well tells the story of the mission, has the telescopes, which operate, of course, in the ultraviolet part of the spectrum, 3 different instruments in the payload bay that the science guys will tell you about in more detail later. But we launched on the 2nd of March. We really didn't think we were going to do that with the weather as it was when we got down there. It was a night launch primarily because we were attempting to maximize the amount of observing time, and as it turned out, launching in the middle of the night minimized the amount of time that we were going to be in the South Atlantic anomaly during the nighttime passes. So we went to the program, the science guys did, along with Payload Commander, Tammy Jernigan, and made the case for launching in the middle of the night, and we did that. We launched at 1:37 Eastern Time. I guess we were a minute late, 1:38 Eastern Time on the 17th. And I can tell you what, or the 2nd, it's my second night launch, and day launches are impressive. Night launches are really something. It gets to be no kidding broad daylight down there at Kennedy Space Center for just a little while.
Although Astro is sometimes talked about as an individual payload, there are actually more than one instrument that come together to make the observatory itself. And in this picture we see, starting from the left, the long conical sunshade you see there is actually part of a star tracker that we use for correcting image motion that are created by disturbances in the orbiter. Just to the right of that you can see sort of in the back is the ultraviolet imaging telescope, which actually takes images of ultraviolet objects, and it was built at Goddard Space Flight Center. And to the right of that, the larger tube is the Hopkins ultraviolet telescope from Johns Hopkins University.
And here's another view of the same telescopes, the same telescope package, the Astro Observatory. The instrument you see in the foreground with the square aluminum baffle is a Wisconsin ultraviolet photopolarimeter experiment, which we commonly just call Whoopee. And to its right, you see 3 small tubes. Those are the baffles for the optical sensor package, which was 3 star trackers that were used in conjunction with the instrument pointing system to help acquire stars and to guide on those guide stars during the observation. This particular image, if you look at the landmass below, has special significance to astronomers. This is in the southern hemisphere, and see if I can figure out how to make this laser pointer work. Yeah, okay. Right in here, in this region, are almost all of the large ground-based observatories in the southern hemisphere. This is northern Chile, and right in this region in here is the Las Campanas Observatory, the European Southern Observatory, and just to the right over here is the Inter-American Observatory. And much of the astronomy in the southern hemisphere is conducted in this region or in Australia. And so this picture has special significance to us. And in fact, the last time I flew on Astro 1, as we were flying over like this, some people I was working with were down here making observations in Chile.
Okay, this is where I get to introduce the crew members. This has got both of the orbital pilots here, Wendy Lawrence on the left, of course, and Bill Gregory on the right. And those 2 folks were on different shifts. We were divided up into 2 shifts and ran 24-hour operations on board the orbiter for all 17 days that we were flying. And Wendy was the blue shift pilot. She ran basically all of the orbital maneuvers that we did. We had over 377 maneuvers that supported the payload, just a little over 400 maneuvers all told for the flight. Wendy basically loaded every single one of those on the blue shift. Bill did all of them except for a few that I managed to screw up on the red shift, and they did an awesome job, not only of keeping track of the attitude timeline to make sure that the orbiter was maneuvered properly to support the observations that the science folks wanted to make with the telescopes, but also just in keeping the orbiter clean, doing all the things for the systems, the flash evaporator systems, the wastewater dumps, all those kinds of things that you need to do in order to keep the orbiter up and running to support science operations. These guys were doing one on each shift. Tammy Jernigan was the Payload Commander. For that matter, still is the Payload Commander until we managed to get the flight report written. And, and she was assigned to the flight. Both she and John were assigned before the orbiter crew was even mentioned in context with STS-67 by about 6 months. So Tammy was working all those issues with the payload community at Marshall Space Flight Center and at Goddard with all the science teams, the principal investigators, to try to get the operations in sync with the science early on. And she did just an awesome job. Here you see her working with one of the many PGSCs that we had. These were dedicated to the payload. We had 3 computers that were dedicated to Astro, and that was our primary interface with the Space Lab system, the SCOS, the subsystem operating software, and the ECOS, the experiment software, to work with the payloads. We had the SCOS running primarily on the starboard side, left side as you're looking aft, which was the MS station, and then the experiment side was primarily run by the folks on the right side, that being the PS. Okay, speaking of one of the PSs, Ron Parise, Dr. Ron Parise, and when we got back to Ellington, I said that he had been assigned to Astro since the Earth cooled, and that's not really completely accurate. However, he has been working Astro since he graduated from college, which was shortly after the Earth cooled. And basically, the guy is an expert on Astro, as you would suspect. He flew on Astro 1 back when Vance Brand and Guy Gardner and Sam Durrance all executed the first mission here. And so he was just a tremendous source of knowledge, not only on UIT, which is his particular area of expertise, but on the other 2 payloads as well. And besides that, he was just a great guy to go fly with, always willing to do anything that was required. He and Sam both were the suit guys for post-insertion and deorbit prep. Sam and Ron were the folks that got all the rest of us dressed in the morning. Here you see Sam on the right, Sam Durrance, and John Grunsfeld on the left. John was a first-time flyer, as was both Wendy and Borneo, Bill Gregory, affectionately known as Borneo. John was the other MS. He was the blue shift guy that ran the instrument pointing system, starboard side aft flight deck. He's also forgotten more about laptop computers than the whole rest of the crew combined ever knew, and he was just a huge help in that area, since we were operating about 6 of those things simultaneously to support the payload and the orbiter. Sam, of course, also flew on Astro 1 with Ron, Vance, Guy, and company, and as such was another super expert. His primary area of expertise being HUT, the Hopkins Ultraviolet Telescope, which he works basically full-time at Johns Hopkins.
The book you see Sam and I holding contains the target procedures. We observed hundreds of targets, and we had an individual procedure for each target that was observed. And as you can see, we affectionately named this book the Rolodex, since it became so full with all the new procedures that the ground uplinked, and we had a little fun with it here in 0G.
Wherever we go, Steve gets the opportunity to introduce all of us, and because he does that, we don't get a chance to brag about him. So I'm going to take a second here to point out that Steve had flown twice previously. This was his first flight as a commander, and he took on the ambitious chore of going uphill with an all-rookie flight deck, his first time in the left seat, and 3 brand new spanking astronaut wannabes fulfilling the rest of the flight deck, and did an admirable job of getting us uphill. What Steve did was basically turn the mission over to the red team and the blue team leaders, and what he did was he supervised us and kept basically the ground in tune with what we were doing and handling any of the problems. And this is a picture of him at work doing what he did best, and that was keeping the ground informed via basically the same email that we use here on Earth. And you can see he's typing on a keyboard, and when issues came up, Steve would use the magical keyboard to talk to the ground, and we got some awesome results. The Johnson Space Center and the folks in Huntsville and Marshall did a wonderful job of helping us out when we were in a bind. We also used this keyboard for communicating with other members of the astronaut office and our families and friends.
I have an opportunity to introduce some of the mid-deck experiments that we carried. These gave an opportunity for Bill and myself to participate in some of the science operations. I'm presently in front of what's called PCG test, protein crystal growth thermal enclosure system. That was one of the protein crystal growth experiments that we had. Unfortunately, you can't see the other one, which was PCG S-test for single thermal enclosure system. And this is another one of another flight in the long, we hope, long series of flights that will continue protein crystal growth on orbit. It's had tremendous success. As far as we know, we had the same success in our flight. They were certainly interested in having 16 days worth of protein crystal growth on orbit. Primarily, we were growing crystals for drug research in this experiment. And the locker that you see on top, the other silver metal box, is CMIX, which stands for Commercial Materials Dispersion Apparatus ITA experiment. The unique thing about this experiment is it's a commercially sponsored experiment in conjunction with the University of Huntsville, Alabama at Huntsville. And I'll let Bill continue to explain what we did with the CMIX experiment.
Yeah, we had a couple portions of the CMIX. We had the box, which you saw just above Wendy, which was the thermal enclosure, and then we also had a pouch assembly that had a variety of syringes which contained different compounds and or life forms. And what we did was, once we got up on orbit, we would push these syringes to activate, and we would have corresponding syringes on the ground that would be activated at the same time. And then later on in the mission, we would deactivate by sending a fixer in by pushing the syringe a second time. And so we were able to model both the ground and up in orbit exactly what was going on, and we filmed these so that they could provide further analysis once we landed.
Another mid-deck experiment we had that was great and kept our commander busy almost the entire flight on the mid-deck was the mid-deck active control experiment. And this is a very good payload that involved a lot of human interactivity, built at the Massachusetts Institute of Technology in collaboration with Langley. And it's a control structure technology experiment. And basically it was a long beam that at one end had a little gimbal assembly that would try and disturb the whole structure. And at the other end, the one that's closest to the left on the screen, had a little pointing instrument in it and gimbals. And the purpose was the disturbing end would try and shake the pointing end, and some computer algorithms and gyros and the gimbals would try and hold the pointing end very, very stable. And this is a model for all sorts of space structures. This was a relatively low-cost experiment, but from what they learned on our flight, with all the runs that both Oz, Borneo, and some of the other crew members did, we'll be able, hopefully, to leverage some great cost savings for building very large satellites, such as some of the Earth observation systems, or space stations, or spacecraft to head out and explore the planets. We also had an experiment on board called SARX. It's an amateur radio experiment, and here you see WA4SIR, aka Ron Parise, talking to one of the school groups on the ground, and we had a record number of contacts, and every one I thought was truly excellent. The kids asked and students asked just wonderful questions, and it was really neat to be able to talk to them and give them real-time feedback. We also had the SARX experiment hooked up to a computer so people could log on to the orbiter and receive a little bit of information. We made over 1,200 contacts where people were able to connect with the orbiter, and lots more where we were just able to talk to folks from all over the world as we passed over on amateur radio.
One of the other experiments that we flew was the Pilot, and what you're looking at here is a computer workstation, and just out of view are my hands holding a second stick. And what this allowed us to do is, through the course of the mission, fly numerous approaches and landings to a simulated shuttle landing site, and we're looking for possible degradation over the period of the 16-day mission. Additionally, this allowed us to practice prior to the actual landing, and Steve, myself, and Wendy were able to practice our crew coordination and our calls and kind of get back into the saddle as far as being prepared for our actual landing.
Unfortunately, we were not scheduled to work all the time. All of us had an opportunity to relax on the bicycle ergometer. John's actually the one doing work, and I'm having a lot of fun playing alongside. It was a great way to relieve stress, just like you would do down here on the ground. We exercised throughout the day. The orbiter folks tended to exercise during the middle of our shift, and we left the pre- and post-sleep period available for the payload crew to hop on the bike. And I think every one of us would feel that we really felt great post-landing because we had had extensive opportunity to get on the bicycle and pedal. 3 of us had an opportunity to pedal around the world. That took about 95 minutes to do, and we thoroughly enjoyed that. The only problem with the current configuration of the bicycle is, unfortunately, you have to look at the sleep stations. If we had been able to set it up the other way, we could have pedaled around the world and actually looked at it at the same time. But it really was a great way to get some exercise and relax while you're on orbit. And those of us on the blue shift had this wonderful opportunity every morning. We got to see good old Borneo Bill wake up and climb out of his sleep station. We had 4 sleep stations installed, which was really a wonderful thing for a dual shift flight. And keep in mind that while half of the crew is up and working, the other half of the crew needs to be asleep so we can conduct our 24-hour operations. And the sleep stations really provided you with a great way to get a good, quiet night's sleep. Personally, I never used earplugs, and I slept great on orbit. It was really kind of neat to be, even though you're inside of a sleeping bag, kind of a cocoon-like sleeping bag that's attached to the walls of the sleep station, you can definitely tell that you are floating, and I thought that was better than any waterbed that I had been on.
Well, as I'm sure you hear from every crew, one of the most exciting parts of any flight is looking out the window. And the Earth observation program actually gives us a real requirement to do that, so it's a great program. And here you see John. John and Wendy were our onboard film and camera folks. They made sure we had plenty of film loaded, that the cameras were working great, lenses were clean, windows were clean. And as Oz mentioned before, we took over 7,000 70-millimeter frames, most of which was Earth observation photography. And one of the very pretty places that we flew over many, many times in the daylight on this flight was Australia. This is a view along the western coast of Australia of an area called Shark Bay. Shark Bay is just a beautiful area to look at from space. There are a number of rivers. This is a very arid desert region, and there are some rivers that flow into the bay, and you see a lot of sediment produced here. Let's see, does this work? There we go. There's, for example, a river coming out here, and you see the sediment plume coming out into the bay. And all of this stuff here is lime and algae deposits that have built up in the bay, but they have these tidal flows going through them that make very pretty patterns.
And this is further across Australia, as our orbit carries us across Australia. This is in the central region of Australia, which is very arid and dry. And you see here the Copper Canyon region, Copper Creek region. And normally these lakes, or these rivers and lakes, are dry. A few times every century they flood and create these very wide floodplains, and you can see the creek here. The floodplain covers this wide area here. There have been a number of rains recently in Australia, and you can see in the sun glint that a lot of the rills in this floodplain are filled with water. You can see the sun glint off of the water. And this lake down here is a lake called Yama Yama, and it is, in fact, you can see water filling the lake. Australia actually did have quite a bit of water in it this time. Normally, this area in Australia is quite dry. And another thing we see from orbit are weather patterns. This is a circulation around a low-pressure area in the southern hemisphere. You can see as the air mass moves in toward the low-pressure area, it takes on this cyclonic circulation, and you see here various lines of thunderstorms forming around the low-pressure area itself.
This is one of my favorite places in the whole world. Spent a lot of time there back when I was in the Navy in a previous life. And here we see Mount Pinatubo. And basically this particular photo will be the baseline for the coming rainy season in the Philippines. This is the big island of Luzon. Here's Manila Bay. Manila's over here, the Bataan Peninsula of World War II fame. And of course Mount Pinatubo with Crater Lake at the top. It's bright blue. And you can see the mud flows that have come down. Clark Air Force Base is located right here. You can actually see the runways there and all the mud flows that have followed the eruption of Mount Pinatubo. The particular area that I was interested in, this is Subic Bay, Cuba Point Naval Air Station. Both Clark and Subic Bay have been given back to the Philippine government now, but we used to drop a lot of bombs on 2 targets right out here, and there's another target right up this way. It wasn't supposed to be a target, but one particular Air Wing commander decided to make it a target one afternoon, which unfortunately was a recreation area for the communication station, and there were a number of families, fortunately, on the other end of the island. But obviously this is a place where a lot of folks currently in the astronaut office spend an awful lot of time, and it's a beautiful, beautiful part of the world.
I have the oceanography background on the flight, so they voted for me to discuss this slide. We're actually looking at the Ritchie Archipelago, which is in the Andaman Sea. That's actually between India and Burma in the Bay of Bengal. And because of the reflection of the sun off the surface of the water, we're able to detect many features of the ocean, in this case circulation patterns. You can detect some of the current that's running along the shore. And as Sam talked about, weather patterns, i.e. in the air mass, the cyclonic circulation, you can also have the same features that will develop in the ocean. You'll have some circular patterns on the ocean surface detected by the sunglit, which we call eddies. Other features that you can detect in this photo, this is a large area in which is experiencing a wind gust, and the wind blowing over the surface is actually forming some linear waves that you can actually make out. And I was quite surprised that we would be able to detect that amount of detail from 190 miles above the surface. And down here in the bottom, unfortunately, you can't quite make it out in the slide, but there is a ship that is traveling out to sea. And that was another fun thing for me, to look out the window and try and look for ship wakes. I'm not in my former life, I'm still in the Navy, and I have a lot of friends who are out at sea right now, so I was trying to track down their boats. Also, as an orbiter pilot, once you've got the maneuver kicked off, you have an opportunity to look out the window. I did that as much as I could, and this is my one claim to fame. I was looking out the window on flight day 6, I think it was, and we were passing over the Andaman Islands, and lo and behold, saw this plume of smoke and realized we were looking at volcanic activity. And this is Barren Island, just to the east of the Andaman Island chain. It had an eruption back in 1991, and it had a subsequent eruption in late 1994, and they had been tracking that, and they were surprised to see that it is gaining in momentum at the rate that it is, and the Smithsonian Institution was interested in our subsequent observations, and so any opportunity we had, we grabbed the camcorder, the Aeroflex, and the Hasselblads and took lots of photos.
Well, this is a picture of the mighty Himalayas, rooftop to the world. And when I was a small boy, I had 2 great dreams, one of which was to fly in space, and the other is to go climbing in the high Himalayas on an expedition. And I think this is certainly the more exciting of the expeditions, but maybe someday I'll get down there. But it was amazing from a couple hundred miles up to look down on this particular part of the Earth and have a feeling for the great relief in the surface of the Earth. There's tens of thousands of feet of difference between some of the low-lying areas in the picture and the top of the mountain. It's just a really neat place to see. And we saw an amazing variety of terrain. As Wendy was talking about the ocean surface with waves being measured in just tens of feet to, at the most hundreds of feet, and here we have tens of thousands of feet. It's really just a beautiful planet. We also saw waves on the surface of sand, and this is in Saudi Arabia, and you can see really 2 prominent types of terrain here. There are the dunes, both linear dunes and somewhat circular dunes, separated by areas where you see many, many small green spots. And those green spots are not natural the way the dunes are, but are actually farmers pumping water from under the ground up to the surface in center pivot irrigation and creating very, very tiny islands in the sand of agriculture. So it's really very striking.
This is one of the more detailed photographs of Oahu, at least that I've ever seen from space. You can see, of course, Pearl Harbor and the international airport. And you can also see waves breaking on the north shore on Oahu. Just a wonderful view, and I'm hoping to get a little bit closer look up after we land, a little bit later this year. I'm still up there in spirit. This is one of the views we were treated to close to the end of our mission. We have, of course, the instrument pointing system doing the fine job it did during the whole flight, and of course the orbiter performed beautifully. Our instruments operated very well, and you can see in this photograph, if I can activate the pointer here, here's the Earth glow. It's about 95 kilometers above the surface of the Earth. Oh, this is a moonlit view with a wonderful stellar background. We were just delighted to be part of this mission. I'm very pleased that the orbiter, the instruments, and the IPS performed so beautifully.
Okay, and every flight needs to have their sunset photo. And to be perfectly honest with you, we don't really know if this is a sunrise or a sunset. They really kind of look alike, and you get 16 of them each every day. And so there were a lot of them, but they're pretty quick. You gotta catch them in a hurry. But it is just dazzling the amount of detail that you can get looking at the Earth's atmosphere with the sun in the background. And we were trying to count the layers of the atmosphere. We finally figured out there were at least 10 that you could detect with the naked eye, and I think you can probably see at least 10 of them here. And it's always amazed me that these thunderstorms that usually are only 40 or 50,000 feet high, that you can actually see those so very clearly with the naked eye in the atmosphere with the sun coming up or going down. It's just a beautiful way, and it can actually distract you from what you're supposed to be doing if you're not careful. It is so fantastic.